Today we are going to discuss friction, which is a very important force in solving problems in statics. Not only is friction very important for solving problems in statics, but it's also a very important real-world phenomenon. A large chunk of the world's energy budget goes in overcoming friction. So it's very important that as engineers we understand friction and we work towards limiting friction. So let's start with this block which is lying on a floor. So this could be, for instance, your bed. Now we just do an analysis of this block right now. We know that it's in static equilibrium. So analyzing this bed, we make this isolation volume. We have this bed which has a mass of m. Drawing all the forces. One, there's a downwards force which is of gravity. There's an upward force which is the normal reaction, and we can immediately see that the normal reaction is equal to gravity. Now this is fine. Now suppose what we do is we introduce a person into this figure who is trying to push this block. Let us say that this person is trying to push this block with the force E. E for effort. And now we immediately see that there is no counterbalance to this force E, that because in the horizontal direction E is the only force acting. So even for a microscopically small volume of force E, small amount of force E, this block should move. Now this does not correspond to a real world experience. Now this is a value, this is something that I'm going to be referring to often, so I'll just write it down. Real world experience. Now we all know that if any of us have pushed a heavy bed, we would know that we cannot push a bed simply by the touch of a finger. This value, this effort E, has to be a certain minimum amount before which we can push it. So let's just assume that this value E is not above that minimum amount, that this is a small amount, say we are just touching this bed. Then how do we solve this balance problem? So the simplest answer to this is that at this contact point, not only is there a normal reaction, but there's also an opposing force. So let's call this opposing force F. This opposing force is caused because of this contact. Hence this contact is important for this opposing force. This F, this force is friction. And now let's do a balance and we'll immediately see that F is equal to E. That whatever effort this person is applying, that is being counteracted by friction. Now while creating this force F, what we had assumed is that this E is sufficiently small. This is a very important assumption, because if we don't keep this assumption in mind, then what this equation can mislead us into believing is that suppose you have a block, say a bed, lying on the floor. You can apply as much force as you want to apply to it, and this will always be balanced. As long as these two equations are balanced, this block cannot move. So this equation is valid only as long as E is sufficiently small. Now the immediate question is, and I'll write this down, how small is sufficiently small? This is a very important question in static friction, and this is a question that we'll solve in the next video.